Definitions of fundamental terminologies related to quantum mechanics. Observable, a dynamical quantity which implies the position coordinate. The components of momentum or angular momentum that can be measured is known as observable. A physical observable is anything that can be measured. Degree of freedom. A degree of freedom is an independent physical parameter in the formal description of the state of a physical system. The set of all states of system is known as the system's phase, and degree of freedom of the system of the dimension of the phase space. The degree of freedom of a mechanical system is the number of independent parameters that define its configuration. Any of the coordinates, a minimum number of which are needed to specify the motion of a mechanical system, is the degree of freedom. Wave. A wave is a phenomenon or disturbance that transfer energy through matter or space with little or no associated mass. Transport for mass transfer. A wave is a disturbance that travels through a medium transporting energy from one location, its source, to another location without transporting matter. A wave is a disturbance in some physical system which is periodic in both space position and time. Stationary waves. A stationary wave is a wave that oscillates in time but whose peak amplitude profile does not move in a space. Stationary waves are the combination of two waves that move in opposite direction but have the same amplitude and frequency. This phenomenon is the result of their interference. Waveform. A waveform is a graphical representation of a signal in the form of a wave. Cycle. One cycle of a wave is one complete evolution of its shape until the point that it is ready to repeat itself. Wavelength. The wavelength of a wave is the length of one complete cycle of the wave. For a transverse wave, the wavelength refers to the length of a wave from one peak, crest, to the next peak, crest. The wavelength can always be determined by measuring the distance between any two corresponding points on adjacent waves parallel to direction of propagation. Amplitude. The distance from the peak, crest, or the maximum distance to the trough, rest, or the resting position of a wave is called the amplitude or height of the wave. Frequency. The number of waves that pass a fixed point per second or per unit time is called frequency. The unit of frequency in the International System of Units, SA, is Hz Hz. 1 Hz equals 1 cycle per second. Period. Time required to complete a full wave cycle is called a period. Phase. The phase is defined as the position of a point in an instant on a cycle of a waveform, moored as an angle in degrees or radians. A complete cycle is 360 degree or 2 pi. The phase shift. The phase shift is how far the wave function is shifted horizontally from the usual position. Wavefront. A wavefront is defined as a surface over which the phase of the wave is constant. Wavefronts usually move with time. For waves propagating in an unidimensional medium, the wavefronts are usually single points. They are curves in a two-dimensional medium and surfaces in a three-dimensional one. Plane wavefronts and spherical wavefronts are particularly important. Plane wave, a constant frequency wave whose wavefronts are infinite parallel planes of constant peak-to-peak amplitude normal to the plane velocity vector, is called a plane wave. Wave vector or propagation vector. The wave vector of a plane wave is a vector which points in the direction in which the wave propagates. It is always perpendicular to the wavefronts. Wave number. The number of waves per unit distance is called the wave's number. Wave number, as used in spectroscopy in most chemistry fields, is defined as the number of wavelengths per unit distance and is denoted by V equals 1/lambda, where lambda is wavelength. It is sometimes called spectroscopic wave number. Quantization or quantization. In physics, quantization is the systematic transition procedure from a classical understanding of physical phenomena to a newer understanding known as quantum mechanics. It is a procedure for constructing quantum mechanics from classical mechanics. Quantum number. The minimum amount of any physical entity or physical property involved in an interaction is called a quantum number. In quantum mechanics, the physical quantities are in general quantized, and as a result these quantities are prescribed by numbers, not essentially integers. These numbers are called quantum numbers. As the idea of definite orbit does not exist, so quantum number n specifies the relative distance of a particle from some common point. E.g., the electron with n equals 2 is at greater distance from the nucleus than the electron with n equals 1, and so on. Quantum states, the condition in which a physical system exists, usually described by a wave function or a set of quantum numbers, is called quantum state. A quantum state can be described by a state vector, a wave function, or a complete set of quantum numbers for a specific system. Electromagnetic waves. In the region of an electric charge there is an electric field. In the neighborhood of an electric current there is a magnetic field. Variation of the fields change the electric and magnetic fields and propagate through space. The propagation of such a disturbance is called an electromagnetic wave. Free particle. A particle moving in a field-free space is called a free particle. Blackbody. A particle which absorbs all the radiant energy falling upon it is called a blackbody. Its absorption coefficient is equal to unity at all wavelengths. Perfectly bulk body. A body which completely absorbs radiation of all wavelengths incident on it is called a perfectly black body. A good absorber of radiation is also a good emitter of radiation, and so a perfectly black body is the best possible emitter at any given temperature. In this lesson, basic terminology associated with the study of quantum mechanics are introduced. Thanks for watching.